So I have defined 20 different categories here: history, science, technology, arts, literature, geography, and so on. If the article falls inside these categories, then it will be classified as that category. But there are some exclusions as well. That's why I have a specific category called others. So we are going to instruct LLM to fit in these articles inside these categories, and if not, then we are going to classify it as others. So we can do the implementation with OpenAI. To do that, we can use OpenAI's Python SDK. So it's pretty much a straightforward process. We have to generate an API key from OpenAI's portal and pass in this API key here, and we can use the OpenAI chat completion to with the model name. So we are going to use GPT 3.5 Turbo, and we can pass in the article and our instructions here. But as I mentioned before, we are going to use OpenAI's endpoint today, but tomorrow we might need to run this experiment with open source models and even the models which runs on your computer. So when I change the implementation from OpenAI to open source model, I don't want to do all the steps right from the beginning. So this is where the frameworks like LangChain and Llama Index comes into picture, which really helps you to write a very common code. And when you change across different models, you don't have to change much in your code. You just have to change the LLM and the endpoint. So for the implementation, we are going to use LangChain. So to initialize the OpenAI's key, I'm going to use getPass. So from getPass, import getPass, and our OpenAI API key will be, if you call getPass, is going to expect a key here. So I'm going to paste the key, and before we initialize OpenAI, we need to set the OpenAI key in the environment variable. So os.environ of OpenAI API key, and my key is in this particular variable, which is OpenAI API key, right? So this implementation basically helps you not to expose your key while maybe when you check in your notebook. So the getPass basically takes your key as a password so that you don't accidentally expose your key into a public community. Okay, so we have set our API key. So we're going to import, we're going to use LangChain's OpenAI module. So from LangChain OpenAI, import OpenAI, right? And our LLM today we are going to use is OpenAI's LLM. So by default it uses GPT 3.5. So LLM is equal to OpenAI. So if I do LLM.invoke, we can pass in a prompt here. So for instance, tell me a joke, right? So here it is. So what we are going to do now is to create a prompt. So let's define a prompt. Okay, in the prompt we are going to instruct the model categorize the following article, and we are going to send in the article, which is article. So let's first pick the first article, so articles of 0, and let's save this to a variable called article. Let's first run the test with one article, and then we can do it in loop. So we have the categories. Okay, sorry about that. So we have 20 different categories here. So we are going to send in the article and categories, which is going to be my categories variable. Okay, so what is the in answer? Okay, let's do LLM.invoke. Okay, let's print the prompt before we categorize the following article. This is my article text, and these are the list of categories that I have, right? And we can also add an instruction if the article doesn't fit into any of the above mentioned categories, please return the answer as others. Okay, so let's print the prompt. Let's go ahead and pass this prompt to llm.invoke of here. I'm going to send in the prompt. Let's run the prompt. Okay, yes, now it is categorizing our article, but as we can see, it's trying to categorize into multiple different categories. So categories for let's rephrase based on the following article content. Identify the category of the article. Okay, and we can instruct return only one category name. So let's go ahead and invoke it again. Now we can see it's philosophy, right? So basically we want to do this for all the articles, right? So let's write a for loop. Let's have answers as a list. Okay, so for let's also have we have the TQDM. So for each article in my articles list, basically I want to do this prompt. I'm going to cut this prompt and paste it here. Okay, I'm going to copy this prompt and paste it here. So this is my prompt. So for each article I'm going to invoke LLM. So my answers dot append of, so we are going to do LLM.invoke of prompt. So we are basically doing LLM.invoke of prompt. Each time the prompt is going to change based on this article variable, and for each prompt is going to categorize and return one particular category, and that will be appended into answers, right? So let's first run it for say first 5 articles and see if we are getting right outputs. Okay, so we have our answers here: politics, science, language, geography and arts. Fine, let's go ahead and run it for 100 articles now. So I'm going to run it for 100 articles and save it inside the articles. Okay, we have the results now. It took 43 seconds to categorize first 100 articles. What we can do is to have a data frame, say port pandas as PD, and we can have a data frame. Our data frame will be pd.data frame of, this will be our article will be the set of articles that we have, and the category will be the answers, right? So let's define a data frame. Okay, here we have to give 100 since we picked only the first 100. Okay, let's print df.head. Okay, let's randomly pick a couple of articles and see if the articles are classified properly. So df.ilog of 0. So anarchism is classified as politics. Let's see 1. Okay, so looks like this is classified as science, right? So let's look at the article content. Let's do a mock of this. Okay, so since it's a science article, it got classified. Let's see, how about this? Okay, this is about the letter A. Let's see what is the category for this. Okay, it's the category is language. That's good. Let's pick the next one. Next one, Alabama is a state, so it's classified as geography. So pretty much we can see that these articles are classified into the respective categories. Okay. Of course, we need to have a separate set of evaluations for these articles and its results. But before we close down, I wanted to reiterate a couple of items. One is about the cost. Since we are using large language models, which is really huge in terms of number of parameters, we need to be aware of how much is going to be costing us. So for instance, if we were trying to classify 1,000 articles and we found out it's going to cost us around $0.04. But imagine you're going to classify the entire Wikipedia dataset, which is almost 6 million articles. And if we count the number of tokens in 6 million articles after pre-processing, it's 7 billion. So the average cost estimation that we will have, followed by $0.5 per million. So it's going to cost us around $3,500 for performing a multi-class classification on the entire Wikipedia dataset, which is much costly for performing this particular narrow task. So this is where we can use large language model as a input for the supervised learning. For instance, if you want to perform a supervised training, you need to have the articles and its associated class. Say for instance, we are going to take a random 10,000 samples or 100,000 samples from our dataset, and we are going to train a model which can perform multi-class classification. Then to train the model, we need the article and its corresponding class or category name. To prepare the dataset, we can use this model, but using the LLM for classifying all these text, we will end up having higher cost. So this is something that we need to keep in mind. There are certain places where LLMs can be instantly used for classification, where your dataset is much low, but the deep narrow tasks, it's much to go with other deep learning models which can easily be trained, which are lesser in size, and it's going to cost a bit lesser than what it costs for API based models. Since we have classified only 100 articles, it's much easier to perform the evaluation. But imagine we have classified more than 1,000 articles. Humanly, reading through each article and identifying the class is going to be very complex. So the evaluation of the output of large language model itself is a very big topic to cover. So in the forthcoming videos, we are going to have a deep down sessions on LLMs and how we can leverage LLMs for different tasks. I hope you enjoyed this video. If so, hit the like button and subscribe to the channel. Thank you.